Hello and welcome to 4.4, the Fundamental Theorem of Algebra. Very fundamental section. Okay, Fundamental Theorem of Algebra. If f is a polynomial of degree n with n greater than or equal to 1, then f has at least one zero. That is, the equation f of x equals 0 has at least one root or solution. It's important to note that the zero of f, and consequently the solution of f of x equals 0, may be non-real, complex. Linear factors. Given the polynomial f of x equals a sub n x to the n, so the standard polynomial we've seen where n is greater than or equal to 1, a sub n is not 0, f can be factored as f of x equals a sub n times x minus c1 times x minus c2 all the way through to x minus c sub n, or these are just constants, possibly non-real complex constants, that's possible, and not necessarily distinct. You may have the same thing. You may have like x minus 1 times x minus 1. Could be a root of multiplicity 2. In other words, an nth degree polynomial can be factored as a product of, this is key, n linear factors. So interpreting the linear factors theorem, the graph of an nth degree polynomial function has at most n x-intercepts. At the most n x-intercepts. You're not going to have more roots than you have the degree. Could be fewer though. And at most n minus 1 turning points. So here's an example. I graphed f of x equals x to the fourth minus 2x cubed plus 1. Okay. So it comes down, turns up a little bit, then turns down again, then turns up again. So what we have is this part right here indicates there's one complex root. I should say two complex roots right there. And then you have two real roots. Plus it goes down, up, so that's one turning point, then down again, two turning points, and up, three turning points. Here's a cubic. It goes up, then down, then up, so it has three zeros and turns once, turns twice. Okay, moving on here. Geometric meaning of multiplicity in general. If C is a real zero of multiplicity k of a polynomial of f, alternately if x is x minus c to the k is a factor of f, another way to say that, the graph of f will touch the x-axis at c0 and cross if k is odd. So if you have an odd multiplicity, so maybe it's x minus 1 to the third power, it's going to cross. But if it's x minus 1 to the 2 power, it'll touch and go back the same direction. It'll stay on the same side of the x-axis if k is even. Further, if k is greater than or equal to 2, the graph will flatten out near c0. And we will see that here. A couple of graphs. Here's x. Oh, this is backwards. This one is f of x equals x minus 3 to the fourth power. So it touches and goes back up. And here is, this is g of x equals x minus 2 to the fifth times x plus 1 to the fourth. So here's our negative 1, has multiplicity 4, and here is 2, it has multiplicity 5, so it's going to cross. It does flatten out near that crossing point. So in example 1, we're going to sketch the graph of the factor polynomial. It was nice they factored it for us. Okay, now our zeros are negative x cubed is 0, so x is 0. X minus 1 is 0, so x is 1. X plus 2 is 0, so x is negative 2. This one is multiplicity 2 though. This is multiplicity 1, or 3. This is multiplicity 1. So we have at 0, at 1, and at 2. Oh, that's negative 2. Now the leading coefficient is negative, so that means it's going to be coming And let's see, it's cubic, 4th power, 6th power. It's going to come from below, come up, come back through, go touch that, and then go back down. It doesn't cross because the multiplicity there is 2. Oh, I have that a little backwards. Let me redo that. 2, 0, 1. Okay. The negative 2 is multiplicity 2. So it comes up, touches, goes down, it's up. There we go. That's how it's supposed to be. Going to go on to example 2 now. It says use the available methods to factor the following polynomial completely and then sketch the graph. So it's a cubic, which means we're going to have 3 zeros. They not all be real. So if we look at our P over Q's, we're looking at plus or minus 5 over 1, 5 over 2, 2 over 1, no. Well, that's just it, 5 over 1 and 5 over 2. Well, I guess I could say plus or minus 1 over 1, 1 over 2. Let's just try our 5 over 2, 2, negative 1, negative 8, and negative 5. 2, it's going to give us 5, that's 4, it's going to give us 10, that's 2, that's going to give us 5, and that's 0. Hey, look at that. So we have 2x squared plus 4x plus 2, set it equal to 0. You can divide everything by 2 if it helps to see this. So it's x squared plus 2x plus 1 equals 0. So it's x plus 1 times, which is x plus 1 squared equals 0. So x plus 1 is 0, means x equals negative 1. So our zeros are going to be 5 halves and negative 1. It was cubic, leading coefficient's positive, so that means we're going to be coming from below and then going up. Now because negative 1 has multiplicity 2, that's going to bounce off that, so to speak. It's not going to pass through it. Come up, touch there, go down, and then go up through. And there is our graph. And I put it at 3 halves, not 5 halves. I guess I could scale it however I want, but just to be consistent. There we go. Okay, moving on to the last page. Conjugate roots theorem. Scroll on to the next page. Let f of x be equal to this polynomial with only real coefficients. So the complex number a plus bi is a 0 of f, and so is its complex. So the point is, if you have all real coefficients and one of the zeros is complex, that means its conjugate must also be there. If a plus bi is there as a root, a minus bi must be there because they'd multiply by each other to get rid of the imaginary portion. So in terms of linear factors, if x minus the quantity a plus bi is a factor, then so is x minus the quantity a minus bi. For example 3, it says use the available methods to factor polynomial. We know that 2 minus I is a factor. We also have complex coefficients, so we don't know, and it's unlikely that its conjugate is there. So I will go ahead and do some synthetic division. 2 minus I goes into 1. Then we have negative 1 plus I, disturbing the negative, then negative 8 plus I, and then 12 minus 6I. 2 minus I times 1 is 2 minus I. Add that straight down, what are we going to have? Just 1. 2 minus I times 1 is 2 minus I. Add that straight down, we're going to have negative 6. 2 minus I times negative 6 is negative 12 plus 6I. You get 0. That means we have the polynomial x squared plus x minus 6. If you set it equal to 0, that means you have x plus 3 times x minus 2 equals 0. X plus 3 equals 0 means x equals negative 3. X minus 2 equals 0 means x equals 2. So the zeros are 2 minus I, negative 3, and 2. I'm going to go to the next page, or bottom of this page. So to construct, we get to construct something now. We get to be polynomial builders. Construct a polynomial function with the stated properties, fourth degree, only real coefficients. So being only real coefficients, if we have a complex root, its conjugate must be there. Oh, look at that. Square root of 7 and I root 5 are two of the zeros, and the y-intercept is negative 35. Okay. So P of x is going to be a times, we have x minus I root 5. That means we're going to have x plus I root 5. We know we have x minus the square root of 7. So it doesn't tell us, doesn't restrict us with anything. I'm going to give us x plus the square root of 7 just to try to get rid of some of these radicals. So P of x is looking like a times x. If you FOIL this out, it's x squared plus 5. FOIL that out, x squared plus 7. So P of x is going to be a times, FOIL this out, x squared plus 7x squared plus 5x squared plus 35. So P of x is going to be a times x squared plus 12x squared plus 35. Now P of 0 is going to be a times x squared, no, 0 squared plus 12 times 0. That's 0. All right, that should be to the fourth power. 0 squared plus 35 needs to equal 35. So 35a is 35, and a must be 1. So our polynomial will just be x to the fourth plus 12x squared plus 35. Okay. And if you've forgotten that multiplication, just FOIL it out. That x minus I root 5 times x plus I root 5, x squared plus I root 5x minus I root 5x minus I squared square root of 5 squared. These go away. It's x squared plus 5. Okay. And that'll do it for this section. So do the homework. It's going to take a little bit of time. Give yourself time to get it done. Send me your questions, and I'll talk to you guys later. Thanks.